All right, I'm going to go ahead and get started. So this is a mobile VR talk. My name is Dan Miller. I work for Unity Technologies as an XR evangelist. That means that I travel around a lot and mostly focus on AR and VR. So if you guys have been following mobile VR, or if you're familiar with the ecosystem, you know that this has been a pretty exciting year so far. We've had a couple new headsets released, and there's also a lot of stuff happening on the Unity front, and I hope to kind of share that with you today. So as an overview, I'm going to talk about some of the new headsets, some of the new things and features that come with them, and some of the new requirements. Then I'm going to go into getting started with Unity, how you can kind of start to take advantage of some things like our new lightweight render pipeline, as well as the post-processing stack. Next, I'm going to talk about controller integration, how you do it, what you can do, the different buttons and things like that, as well as some specifics on the mappings. Next, I'm going to talk a little bit about controller interaction. So this is something that I've been playing around with a lot. If you're familiar, you know that the mobile VR ecosystem right now has some limitations of what the controller can do. And so I'll talk a little bit about how you can start to expand upon that and think about it differently. And last but not least, I'll talk about some kind of future considerations, general tips and things like that, and what I think you guys should really start thinking about as you're developing for this ecosystem. All right, so if we're looking at mobile kind of in the current ecosystem, and this was a little bit more relevant last year, but now we've evolved a bit, and we have two new headsets that were released earlier, the Lenovo Mirage Solo, which is in the Daydream category, and the Oculus Go, which is obviously a product of Oculus. And so I'm mostly going to be focusing on these headsets. These headsets now all support controllers. The Gear VR was the only one to launch without a controller support, but has since had a controller released for it. And more importantly, I'm kind of going to be focusing more on this high end, so this standalone headsets. And so a couple things to think about here, and what kind of differentiate these two newer headsets, is that the Mirage Solo actually has the ability to run at 75 frames a second. So that's going to be a jump up from the original Daydream, which was targeted just at a max of 60. And the Oculus Go actually runs at 72 frames a second, or has the ability to. Now, if you're submitting apps to the App Store to be compatible with these headsets, there is a couple kind of usage tests there. For the Solo, it has to run for 30 minutes at 60 frames a second. And for the Oculus Go, it has to run at for 45 minutes at 60 frames a second as well. Now, besides some of the kind of display and refresh rate, there's also differences in that the Lenovo has the ability to track itself. So this means it kind of has basically sensors on the front that can understand where it's at in the world. And then as you move, it is able to positionally track itself through the space. And what this means in a kind of mobile context is that you have the ability to kind of move around and move throughout your space in a much more kind of interesting and intuitive way. Now, another big thing that the Lenovo provides is the fact that when you move, the world is static, just like how we move in real life. And this actually really increases the comfort level that's possible with mobile VR. On things like the Oculus Go, where it only tracks its rotation, if you start to move and the whole world moves within you, it can be a little bit kind of nauseating or disconnected. And so this is where we're at with mobile VR. Now, the Oculus Go also has some better kind of rendering features where they've added fixed foveated rendering, which allows for much clearer pictures and things like that, as well as kind of updated the controller. And I'll get into a little bit of the details from that. So while these are both kind of mobile standalone headsets, they have some companion apps that you can connect to your phone, they are kind of all contained within it and have a little bit of differences there. So now I'm going to talk a little bit about getting started with lightweight render pipeline for VR. So if you're familiar with the kind of 2018 cycle that we're moving towards, we've released something called the Unity Hub. So the Hub is a way that you can start projects as well as kind of manage your installations of Unity. If you're like me and you have 10 plus installations, it's really been a breath of fresh air. And the nice thing with the Hub is that it actually provides templates. So when you go and you start a new project and you're in, or you've selected the 2018 version 0.1 or above, they had a little drop down that used to be just kind of a 2D, 3D checkbox, and now we're actually shipping full project templates. In these templates is a lightweight render pipeline for VR. And the nice thing is that it kind of comes with this little construction set that you see here. It has things like the post-processing stack all set up, and it's also just configured and changed the default settings. If you're familiar with Unity and the default settings that you get when you start a 3D project, they've been pretty static and haven't really changed much throughout the years as the platform and the engine has evolved. And what these templates allow us to do is go in, kind of tweak some of the settings and make them more applicable for the platform that you're developing on. Now, one thing to keep in mind is that this lightweight render pipeline for VR template is kind of targeted more towards the high-end VR. So some of the settings and some of the things like post-processing, you might have to be a little bit careful about. But one of the really nice things, and that I really want to point out here, is that it has what we call a generic XR rig. And what this is it's basically a hierarchy of transforms that have tracked pose drivers as well as the main camera kind of parented under them. And it's set up to be kind of a generic rig so that if I kind of play the scene on a high-end VR headset, I have a representation of hands. Or if I play it on a mobile VR headset, it actually has both a right and left hand. And when you're using mobile, you kind of choose the handedness when you're setting up the project. One thing I do want to note, though, and this took me a little bit longer to realize than I'd like to admit, is that there's no visual representation of the hands. So they have tracked pose drivers. Those are going to be transforms that are moving, but you're not going to see anything unless you put something like a cube or a sphere underneath those transforms. So just keep that in mind when you're starting to build for these. And a couple things to note as well, and this is just kind of what the stage we're at with the lightweight render pipeline, is that post-processing V2 does not work, so it's going to be disabled in the pipeline itself. I am talking to the engineers kind of on the Unity side, and things are being worked on, and we think we have a patch that is able to fix that, so that's exciting. And lastly, right now, for lightweight render pipeline, you need to disable MSAA, so multi-sample anti-aliasing, or you're not going to get anything rendered. So this is just a checkbox that's available on the camera, and you can kind of just uncheck that, and that's going to allow you to actually see things. All right, so why would you use lightweight render pipeline? Well, off the bat, you're going to get some performance gains just because of the way the rendering is working. You can see some of the kind of benefits down there at the bottom, and I was really excited to find out using this benchmark scene here. So you might recognize it as kind of the nightmare scene. And what we did is, we use this to kind of benchmark and test performance where we have a built-in or the legacy renderer, all of it set up. I built it out to the Oculus here, and you can see there that with the built-in, I was able to get around 46 frames a second. And as I kind of alluded to earlier, you really need to be hitting 60 frames a second on these mobile headsets in order to get the kind of comfort as well as the certification that you want. With the lightweight render pipeline, off the bat, I was able to get up to 60 frames a second and kind of stay there using the Oculus Go. And then using the Oculus VR Utilities, you can actually enable the fixed foveated rendering as well as kind of increase that performance so that it's running at 72 frames a second. And doing those, using the utilities, I was able to get the 72 frames a second. I have a little build on here if you guys want to check it out after. Looks pretty good, and it runs really smooth. And with the Oculus Utilities, I'll kind of allude to those a little bit earlier, but it's super easy. Basically enabling the foveated rendering as well as pushing it up to 72 is each just a single line call once you've kind of included those in your project and you're using the camera rig. So, if you're starting off right now, it's really kind of a good idea to really start to look at the lightweight render pipeline and how it can kind of benefit your project. Now, there's a couple things to keep in mind, as well as some kind of limitations that you might need to consider. And this kind of is more applicable depending on what your project is and really what you're trying to build. So a nice thing about the lightweight render pipeline is that it's currently compatible with the shader graph. So if you're using the shader graph to kind of author your shaders or make some interesting effects, right now it's kind of only available for the lightweight render pipeline. And you're also kind of future-proofing yourself. You know, moving forward with Unity, the built-in or legacy pipeline is going to still exist, but we're moving a lot of our things as well as adding new features to this lightweight pipeline. So it's definitely something to consider. And then lastly, you know, how we're moving a lot of our projects over to GitHub. The render pipeline is open source. So if you wanted to go and check that out, you're kind of freely available to do that. You could potentially modify it where you're either adding in certain VR capabilities or stuff like that. You can see there down at the bottom, I have listed a couple limitations there. Things like you're only basically allowed 5 lights, 4 point lights, and 1 shadow casting directional light. So kind of the look and feel, depending on what you're going for, could be potentially a little bit limiting. Now, the other thing to note is that the way the lightweight render pipeline works is that if you're grabbing assets from, let's say, the asset store and they haven't been configured for lightweight, they are just going to come in rendering pink, and you're going to have to kind of reset up those shaders. That's kind of just the current workflow from going to legacy into lightweight. So that's something to maybe keep in mind if your project is using something like a lot of asset store packages. All right, so I've said, you know, I've talked about the post-processing stack a little bit. It's currently kind of disabled on the lightweight render pipeline. You can see that there in yellow, but it does work in the legacy renderer. And while, you know, the post-processing stack is really nice, and it's what you're going to use to kind of get some final touches on your project, in general, it can be fairly expensive for mobile, whether it's VR or not. And so doing some performance tests and trying to kind of push the project and set up some scenes, I actually had difficulty getting it up to the 72 frames a second that's possible with the Oculus Go. I was able to get it at 60 frames a second, but in general, it's kind of expensive. So you have to be careful either what effect you're using or how many you're using. So that's just something to kind of keep in mind. And you can see there that it works in multi-pass and single pass. And another one of the performance kind of struggles that I had is that I wasn't able to use this single pass instance rendering, which is basically a way that we can do kind of less passes on the scene so that it renders more optimally to both eyes. So because that's kind of disabled or not working, you're kind of losing some performance there and then kind of using it. Right now, the HD render pipeline just does not support VR. So if you're trying to use that on high-end or low-end or mobile, you're going to have a bad time. And just kind of in general, talking about, you know, what works in VR and what doesn't. So you can do things like color correction, bloom, vignette, all of these kind of normal post-processing that you would expect. Again, be a little bit careful going too overboard. Things like depth of field and grain do work in VR, but they can kind of be a little bit disorienting. You know, usually our depth of field is something that we control naturally with our eyes. I'm focused over here. Everything else is blurry. But, you know, doing that too often or in the wrong context can be a little disorienting. So next, some things that don't work is basically motion blur and screen space reflections. All right, so now that I've kind of overviewed a little bit of the lightweight render pipeline, I've talked about the new ecosystem, I want to go in and start talking about controllers, how you can use them in Unity, kind of what's available and how they work. So I have an Oculus Go controller here, as well as a Daydream one. And you'll see that the Oculus controllers in the ecosystem, so the top one there is the Gear VR, the bottom one is the Oculus Go, are a little bit different. They actually have the exact same buttons. So if you had an application that worked on the Gear VR and was taking advantage of the controller, kind of porting it over to the Oculus Go is not going to be that difficult, as it does use the same buttons. And you'll notice here with the Daydream that it also has kind of this touchpad, that's the circle there at the top, as well as a couple buttons on the bottom. One thing to note is that the Oculus Go has a trigger. So the Oculus ecosystem has an additional button that is not represented, or that there is no representation of on the Daydream. So just something to consider when you're developing. If you're trying to go multi-platform, think about kind of interactions, what buttons you're using, and that you are going to be one button down if you move from Oculus to Daydream. All right, and so just kind of talking a little bit more about the controllers, so you can see that they both have kind of touchpads at the top. You can use these in a variety of different ways. There is a little bit of a difference between the two touchpads, and I'll lay that out here in a moment. You'll notice that they have certain keys, and so things like the home button and the volume key on the Gear VR controller are actually restricted. You can press them, but you can't really add logic to them in your application. And you can see here with the home button on Daydream, it's actually, you can press it, but if you press and hold it, that's going to be kind of recentering yourself. And that is actually kind of restricted there as well. And then we have the Oculus Go controller here. And you can see there at the bottom, that bottom kind of little Oculus button is reserved as well. So those are kind of reserved for the OS. It's going to pop you out of the application and go into a kind of idle state there that you can either resume it or close. And then you can see we have the additional kind of touchpad, trigger, and back button there. All right, so for the Unity integration right now, if you're basically trying to build out an application for any of these headsets, right now it is not required to get the additional SDKs, but there are a lot of really helpful utilities, and there are a lot of kind of nice work going into them, and certain input is restricted where you need the SDK. So if you're not familiar, right now in Unity, we've moved a lot of our VR settings for things like mobile into an XR settings tab. And so in order to enable it, you can just click the checkbox, and then there's a little plus sign down at the bottom to include the associated SDK. So this can be Oculus or Daydream. And if you just check this checkbox and built out your application as kind of an APK, pushed it to the device, then your main camera would just be taken over and would start rendering in VR there. Now, one thing I want to note, and this is something that's kind of a built-in utility that we added to Unity, is what we're calling a tracked pose driver. And so you can see here that I've actually configured it to be a left controller. And what this is it's a built-in component. You can kind of add it to any object in your scene. And then you can configure it with certain drop-downs. So we have generic XR controller. We also have things like color camera, which you would use for like AR. And once you've configured it with the controller, then you can choose left or right. And again, how I mentioned, when you're starting and setting up one of these headsets, you actually choose the handedness. So I'm right-handed, so for this one I chose right hand. And if I were to set up and kind of render this controller right now and only have a representation for the left hand, then my controller would not be kind of fed the data from the SDK as it's moving. And you'll notice as well that in the tracking type, I've listed rotation only. And that's because these controllers do not know its own position in space, but it can use some kind of sensors inside of it to know its rotation and orientation, but not where it's at. Doesn't know if it's here or if it's here. So you can basically configure these to use this generic tracked pose driver. And then if you're targeting multi-platform, this kind of puts a level of abstraction on top of your app. And so this can be really convenient for, again, if you're targeting something like the Oculus and trying to port it over to the Lenovo or the Daydream ecosystem. But something to note here is that the input right now, native input, is currently supported for the Oculus ecosystem in 18.2 and is coming in the future for Daydream. So if you do want to start using the buttons and do more than just motion, you are going to need those additional SDKs. And so the last thing I wanted to show here on this slide was just the integration for Daydream. So it actually has a little drop-down window next to it. And in that drop-down window, you can configure various settings here that kind of get built into your app. And you'll notice at the very bottom there, we have the positional head tracking. So this is what enables you to take advantage of the Lenovo. And you can see here that I've configured it to be supported. So if you build your application and you want to build it out to Daydream that's able to track itself positionally, you are going to need to recompile your app if you kind of had a previous Daydream app and make sure that this checkbox or this drop-down is properly listed there. All right, so I mentioned the utilities, and both Oculus and Google have provided some really awesome tools to kind of support the Unity ecosystem here. So for those, you can just go to kind of developer.oculus.com, grab these utilities for Unity. One thing to note is that these utilities encompass the entire Oculus ecosystem. So you are going to get some stuff for the high-end headset there, the Oculus Rift, as well as the Daydream. And if you're building for Gear VR, you know that that requires the use of an Android device that you kind of plug into the device. And for that, you'll need to kind of create an additional file called an OSIG file that you actually configure and include in your APK there. So some of the things that are included, for me, one of the most helpful things is this little scene that I have down here. It's actually just a generic controller scene that has a huge UI listing the state and the data from all the kind of readings from the controller. So this is super easy to go in here and say, you know, as you're kind of moving the controller around or as you're touching it, like, oh, okay, you know, the axes or the touch axes, the input on the touchpad is equal to this when my hand's on the far left, and et cetera. And you can see kind of the states how they're configured kind of at each step as you're pressing buttons and things like that. There's also things like the controller prefab. We have the 3D models and stuff like that if you want to represent these controllers completely accurately in your application. And there's also some camera emulation, so you can start to test your app a little bit in the Unity editor. For Google VR or for the Daydream, we are like Google provides and builds this GVR SDK for Unity. You can see it's fairly up to date, similar to the Oculus one here, and that's just available on GitHub. Personally, I find it really nice when companies like Google or Unity put things on GitHub because you can actually follow some of the progress, you can see issues, you can see some discussion and what's getting fixed. So you can just grab that there, and then there's just a release tab here where you can go and download it. And as well as the Oculus Utilities, there's also the GVR SDK, which provides some nice things like the Daydream controller model, some example scenes, how to kind of configure and set up for usability of the controller. It also actually has its own kind of shader pack where they've optimized some shaders for mobile. They've also included things like their own sort of lighting model to try to really be able to get the maximum performance out of these mobile headsets. And they've included a kind of spatialized audio system. Previously, that was kind of included in it, and now they're releasing that for all platforms, not just mobile, and it's called Google Resonance, if you guys are interested in that. All right, so I just want to kind of briefly go over controller input before we start kind of moving on to a little fun stuff. So basically, for input on the Oculus, you're going to use the OVR Input tool. You can see that there's a couple different things with kind of getting buttons down, different states, similar you'd expect in an input system. And the one interesting thing here with Google is that they've actually provided some swipe gestures. So if you're swiping there, you can get specific callbacks at what stage you're swiping. One thing to note, and this is something I kind of ran into, is be a little bit careful of normal input that you have within the input system. It can kind of override it and block some of the input that you're getting from the controller. So don't do that. You can see some of the mappings here. I am going to try to kind of go through this a little bit quickly so we can get to a little bit more of the fun stuff. If you guys do want access to these slides or anything afterwards, I'm happy to provide those. But you can just see kind of how these work. There's both a touch and a press on these touchpads, so keep that in mind, and then an axis 2D at the actual position that you're touching. And then for the swipes, we just have those kind of as buttons. So similar on the Google VR input, where you kind of query things at a static reference there. You can get sort of app buttons, and you can also get access to the gyroscope and the accelerometer of the actual controller. And you can see here, similarly, we have these mappings for kind of the touchpad, the app button, and something like that. So this was something I wanted to just point out quickly here, is that these are the touch kind of axes for each of the controllers. And you'll notice that the Gear VR and the Oculus go from 0 to 1, where the Daydream actually just goes from 0 to, or like 1 to 0.5 there. So just kind of keep that in mind, how it's kind of set up a little bit different. And the 1, 1 is down in that bottom right-hand corner. All right, so now I just want to talk a little bit about controller interactions. So right now, all of these controllers are limited to kind of 3 DOF. So you're only kind of moving it around a little bit using the accelerometer and gyroscope, and then it knows its position rotationally. And so something that I've been working on a little bit is what I'm calling the Keyturn Interaction. So I got this idea from a friend who's building a lot of VR games, and what I'm doing here is as I rotate my controller, I'm kind of extending out a little ball or something like that that you can actually go and interact with elements. The one thing I found, especially when demoing a lot of mobile VR, is that when you put your friend in it and you give them the controller, if they've tried any sort of high-end VR, everybody is always kind of reaching. They're always trying to go out there. They're always trying to walk forward or just grab things. And so I think that providing some sort of way that your user can kind of extend out a little bit and interact with objects that are a little bit further away is really a good idea. It just makes things feel a little bit more intuitive. And the nice thing about this, I've found, is once you start to kind of try it and get comfortable with it, then it becomes fairly intuitive. You can kind of grab objects forward and things like that. And so I have a little example here where I've hooked up some input to it, and you can actually go out and start to grab things because the controller's not going to know if it's here or if it's up there. But you can see you can kind of go, use the controller, and then turn it back. And the other thing is, too, is when you're kind of moving this controller around, you don't really, there's not a whole lot of these interactions where you're doing this key turn. You're mostly kind of swiping it around like this, maybe an up and down. And so this is kind of a less used object there. You can see I try to stack this up almost. But yeah, this is just kind of an interesting interaction that I've been playing around with a little bit and really gives kind of a little bit of the depth back to the user, and that's kind of nice when you're more limited. Do I try again? No. All right, so just kind of the quick code snippet for this. I think the text is getting cut off there, but basically I'm just querying the rotation of the controller. This one happens to be set up for that Gear VR controller, but really if you're using the tracked pose driver, you can do that at any state, and then just kind of saying, am I between this little rotation between these two values? If so, kind of extend it. And then if I go beyond it, it actually comes back a little bit too. And it comes back twice as fast as I'm kind of extending it there. All right, and so the next thing I wanted to show is this is kind of a little mobile game I've been working on. And what this is this is kind of just adding a little bit of juice or interactivity. With VR in general, I think it's really important to have a lot of kind of subtle interactions within the experience that really kind of enhance it and give it more life. And what I'm doing here is I have this little bug net, and I've actually rigged it up so the entire kind of shaft of the net, as well as the 2 little antennas at the top, all have bones, but there's no animations associated with them. So I'm using basically a tool or a package put out by our Japanese team called UnityChan Springbone 2.0. You can see it listed on GitHub right there. And what it was originally used for is actually these big kind of ponytails for the UnityChan model. And what it is it's kind of this physics-based system that isn't using Unity joints and instead is just kind of calculating some of the physics from there. And I'll show this a little bit here in a moment as well. And you can see how when you add a little bit of this kind of inertial movement and kind of interaction in the experience, it can be pretty fun and kind of makes it feel a little bit more cartoony and things. All right, so that was kind of the interaction stuff, and I want to show one more example with that net there. But first, I just want to list off a couple really nice tips, things that I've found really helpful, especially when starting to develop for mobile VR. There is a blog post that was recently released by Oculus that is called basically tuning settings for mobile in Unity. It has things like texture compression, player settings, audio, and it lists off a ton of different checkboxes, settings, things like that. I highly recommend checking it out. It's really thorough and well done. There's also things called Daydream Elements. So this is a package put out by Google that provides a lot of things like controller, UI, interaction, as well as some 3D models and things like this. So this is going and kind of picking up models. It also has a utility for actually kind of rendering just a tunnel so that you can feel a little bit more comfortable when you're doing some kind of locomotion and things like this. And this is just completely open source. It was obviously built in the Daydream ecosystem, but really it's just assets and scripts for Unity. And the last thing is Google's Instant Preview. And I want to see if I can get this working. And what this is this is actually the ability to run the Google VR kind of Daydream ecosystem on a mobile device. This is kind of driven through my mobile device here. And then I can go and connect my controller. If I turn it on here, let's see it. And then you can see I can actually kind of move this net around. And so you can see how the net actually moves down there at the bottom in my scene view as I'm kind of moving this controller. And you can see the antennas at top kind of jiggling around a little bit as well. So this is a super convenient tool for kind of debugging and developing your application in the Unity editor. So this is just Daydream Instant Preview. It allows you to build it up, kind of push a APK to device, and then since you're in the Unity editor here, it's super easy to go and debug, kind of check the state of objects and things like that. And you can see that, that spring bone there kind of happening as I'm moving it around. All right, that demo went surprisingly well. Last thing I just want to mention is be sure to adjust your default camera. If you start up a new project, the default kind of near clip plane is going to be set to 0.3. And a lot of things, like your controller specifically, is just going to be clipping through that near plane. So you can see here on the right, I've actually adjusted it so the controller isn't lost. This video on the left is not working, but it's a bad video anyway because it shows when it's too close, and it really starts to clip through. And the thing with mobile VR is that your controller is kind of always there next to you off to the side. So keep that in mind. Looks like it's rendering. You can see. All right. Last, I just want to mention this. This is huge if you've been paying attention to what we're doing with ECS, and if you're a mobile VR developer or just a VR developer in general, performance is always crucial. The Entity Component System, or ECS, is a way to start to tune your applications in general to get more performance. So to me, this is kind of a perfect use case for something like mobile VR. I think everyone should really start to kind of look at this, understand how it works, and see how you can switch over some of your systems to start to utilize this to be more optimized and run a little bit faster. All right, so that's pretty much it for my talk. I'm not sure if we have any time for questions, but I'll be kind of around outside or throughout. If you guys have any questions, feel free to reach me via email or follow me on Twitter there. I post a lot of kind of VR-related stuff. So thanks.